Hi, hello everyone. Welcome to SK Academy of Mathematics. Today, let us learn how to solve the problem on triple integral, where they have given the integral with respect to 0 to 1, 0 to root 1 minus x square, 0 to root 1 minus x square y square, dz dy dx divided by root 1 minus x square y square minus z square. How to represent, how to solve, and how to represent this solution. Now, let us see. First, let us represent the given integral. Okay, solution. I, which is equal to, always it should be represented by capital letter I, 0 to root 1 minus x square, 0 to root 1, 0 to root 1 minus x square minus y square. Okay, let us write properly, into dz dy dx divided by root 1 minus x square minus y square minus z square. Okay, now see, if you look into this problem, if you check the denominator, or if you separate this equation, I need to integrate 1 by root 1 minus x square y square and minus z square, but it will be little bit difficult. To reduce this problem, what we are going to consider? We are going to consider k, which is equal to root 1 minus x square minus y square, which implies k square, which is equal to 1 minus x square minus y square. I am going to reduce this with respect to this. Why? Because we will get to know now. Okay, before this part, we need to represent the limit point. See, first let us represent the limit point. See, since the upper limit point is defined with respect to x and y, I need to compulsorily or strictly integrate with respect to z itself. Z is done. Now, see, the second integral is integrated with respect to limit points are 0 to root 1 minus x square. Since it is defined with respect to x, I need to integrate with respect to y itself. Remaining last integral is with respect to the remaining variable, that is x. Now, let us represent this one. I, which is equal to x varies from 0 to 1, y varies from 0 to root 1 minus x square. Got the point? Yes. Now, after this, we have z equal to 0 to root 1 minus x square y square can be written as k into 1 by root k square. See, 1 minus x square minus y square, just this term I am going to replace it as k square minus z square dz dy dx. Got the point? Yes. Now let us integrate this part. This one, we know that integral of 1 by root a square minus x square is equal to sine inverse of x by a. Got the point? Yes. I, which is equal to x varies from 0 to 1, y varies from 0 to root 1 minus x square into, now what we have represented, 1 by a square. Instead of a we have k square minus, instead of x we have z square. So what we are going to do? Sine inverse of, instead of x we have z, by instead of a we have k. The limit varies from z varies from 0 to k dy dx. Done. Now upper limit minus lower limit. When you have trigonometry function, apply both upper limit and lower limit. 0 to root 1 minus x square into sine inverse of, instead of z upper limit is k by k minus sine inverse of 0 by anything 0. Okay, we can represent directly 0 by anything, that is 0 dy dx. K get cancelled, you get sine inverse of 1. I am going to erase this part. Okay, that is I, which is equal to x varies from 0 to 1 and y varies from 0 to root 1 minus x square sine inverse of 1 minus sine inverse of 0 into dy dx. Got the point? I, which is equal to x varies from 0 to 1. Now y varies from 0 to root 1 minus x square, where sine inverse of 1, if you don't know the value of sine inverse of 1 or any value, just use the calculator, you will get the direct solution. Sine inverse of 1 is pi by 2. Okay, I am going to show you, that is sine inverse of 1. See, in the place of sine we have upper term in the yellow color, so shift sine inverse of 1, you get pi by 2. Sine inverse of, again apply sine inverse of 0, that is 0. dy dx, pi by 2 minus 0, pi by 2. Pi by 2 I am going to take it as outside, that is pi by 2. X varies from 0 to 1 and y varies from 0 to root 1 minus x square dy dx. Now I need to integrate with respect to y. Since I don't have any variable to integrate with respect to y, there is a constant term, that is 1. Integration of 1 with respect to y is y, that is I, which is equal to pi by 2 integral x varies from 0 to 1 into y integration. See, integration of 1 with respect to dy is y into y varies from 0 to root 1 minus x square dx. I, which is equal to pi by 2 integral x varies from 0 to 1 root 1 minus x square minus 0 dx. I, which is equal to pi by 2 integral x varies from 0 to 1 root 1 minus x square dx. There is a standard formula for, that is, there is a standard formula, that is integration of root a square minus x square. This is the standard formula, where this standard formula we are going to represent it as, that is x root a square minus x square divided by 2 plus a square into sine inverse of x by a whole divided by 2. This is the standard formula. Now, in place of a, we have 1 square. In place of x, we have x square. Just simplify. I, which is equal to pi by 2 into x. In place of x, we have x itself. X into 1 minus x square divided by 2 plus, in place of a we have 1 into sine inverse of x by a, that is 1 whole divided by 2. Got the point? Yes. Now limit varies from, x varies from 0 to 1, but I, which is equal to pi by 2 into, apply, okay, let us reduce by x minus x square by 2 plus 1 into sine inverse, x by 1 is x, that is sine inverse of x by 2. Now let us apply upper limit and minus lower limit, that is I, which is equal to pi by 2 into 1 into root 1 minus 1 square divided by 2, this is the upper limit, plus sine inverse of 1 divided by 2, this is your upper limit, minus, now we have the lower limit. In place of x, we are going to put 0 root 1 minus 0 square divided by 2 minus sine inverse of 0 divided by 2. Okay, this is your lower limit. I, which is equal to pi by 2 into 1 minus 1, 0, 0 plus sine inverse of 1. We have, what is sine inverse of 1? That is pi by 2. Already we have represented, that is sine inverse of 1, which is equal to pi by 2. Sine inverse of 0, which is equal to 0. Sine inverse of 1 is pi by 2 divided by 2 minus 0 into anything 0, sine 0, 0. where I which is equal to pi by 2 into pi by 2 you get pi by 4. I which is equal to pi by 2 into pi by 4 we have pi by 8. This is our required solution for the given triple integral, which is the one of the most important question which have been asked repeatedly in V2 main examination. I hope you have understood how to represent the given integral and how to represent the limit points and how to solve the given integral with respect to given variable z, y, x step by step and represent and apply the limit points and represent the given solution with respect to I, that is I equal to pi by 8. I hope you have understood this problem step by step and a perfect method of solving the given problem. For more videos, please do like, share and subscribe. See you in the next video. Thank you.